Hi, my name's Ben, and in this short video we're going to be looking at finding the prime factors of a number. Now it's important before we start that the children understand what we mean by prime numbers and factors. Now a prime number comes when it's only divisible by itself and 1. For example, 13. 1 times by 13 is 13. When we deal with factors, we look at them in pairs. So two numbers that multiply together to make that number. If we took 20, for example, that'd be 1 times 20, or 2 times 10. They're some of the factors of 20. If we look at these numbers here, these are all prime numbers. So 2, 3, 5, 7, 11 and 13. It's really important that the children have a real good understanding that 1 isn't in here, 1 is a square number, 1 is not a prime number, and that 2 is the only even prime number. Any other number that is even is obviously divisible by 2. So once the children have an understanding of prime and factor numbers, they can then go on to find prime factors. If we look at the number 40, which is an even number and therefore not prime, this is a composite number. We can use a factor tree to try and find out what all the prime factors are. So we could find the factors of 40. 1 times 40, 2 times 20. I've taken 4 times 10. Both of these numbers here are composite and not prime, so we have to extract factors from them again. So to make 4, we could have 1 times 4 or 2 times 2. Now 2 is a prime number, and therefore I can circle it, and that branch of the factor tree is now closed. So now let's look at the other side. We have 10. Now factors of 10 are 1 and 10, or 2 and 5. So we'll look at 2 and 5. Again, both of those are prime numbers, so I can circle them. And now that branch of the factor tree is closed. There are no more numbers to deal with, so I'm just left with 2, 2, 2 and 5. Now in any prime number, when you get all the final prime numbers there, if you multiply them together, you will get the number that we started with. For example, 2 times 2 times 2 times 5 equals 40. This is really useful for when you're looking at larger numbers and you're dealing with prime factors. Having a really good understanding of what makes that number is really beneficial for the children. For example, we could start with the number 42 here, and we could look at other factors, 2 times 21 or 3 times 14, and then coming all the way down and finding the prime factors. Would there still be those same at the end? That'd be a really good experiment and exploration for your children. And that is how we can find prime factors.